This video will review over how to perform stoichiometry calculations, specifically mole-mole problems. Now, mole-mole problems are the beginning of stoichiometry, and it is very important to master these problems, as future problems will incorporate and build upon mole-mole solutions. When performing mole-mole problems, we will calculate the number of moles of one substance that will react with or be produced from another substance. The equation used is given moles of chemical A times our coefficient of chemical B over coefficient of chemical A. That will allow our moles to cancel out and leave us in moles of chemical B. So what exactly is A and what exactly is B? Well, chemical A will be the chemical that we are given information about, and chemical B will be the chemical we have to solve for. In order to do these problems, one must have the given moles of one chemical and be given a balanced chemical equation. So let's look at a mole-mole calculation problem. How many moles of oxygen react with 2.25 moles of nitrogen? Now notice that we are given information about nitrogen that makes nitrogen chemical A. We are asked to solve for moles of oxygen that makes oxygen chemical B. We are given a balanced chemical equation. Therefore, we will take this information and plug it into our formula from the previous page. Here we have 2.25 moles of nitrogen as our given from our problem. We will have our coefficient ratio. Now we will have coefficient B on top. That's the coefficient for oxygen. We will have coefficient A on bottom. That's the coefficient for N2. So we have 2.25 times 1 mole of O2 over 1 mole of N2. Moles of N2 cancel out, and therefore we would have our answer as 2.25 moles of O2. Let's look at a second example. Here we are given a balanced chemical equation, and we are given the following information. How many moles of H2O are produced if 2 moles of O2 are used? First, let's identify chemical A and chemical B. We are given 2 moles of O2. That makes O2 chemical A. We are asked to find moles of H2O, making H2O chemical B. We will now use that balanced equation to solve our problem. We take our given moles of chemical A times our coefficient ratio. Now notice that we have our coefficients for chemical A and B. It allows us to cancel out of moles of oxygen. We do our math, 2 times 6 divided by 5, and we have an answer of 2.4 moles of H2O. So notice that a correctly balanced equation was essential to getting the correct answer. Finally, one last example. We're given our balanced equation. How many moles of NO are produced in the reaction if 15 moles of H2O are also produced? H2O is chemical A, NO chemical B. We put our 15 moles of H2O as our given times our coefficient ratio of chemical B on top, chemical A on bottom. Moles of H2O cancel out. 15 times 4 divided by 6, and we get an answer of 10 moles of NO.